All right, so today we're going to take a look at 2.4 part 2, which is on two different transformations. We're going to look at what are called amplitude changes and vertical shifts. So first one we're going to look at is what's called amplitude. So what the amplitude is it measures the height of the wave. Okay? And by the height, I mean the distance from the center to the peak, which should also be the same as the center to the bottom. Okay. So that's amplitude. And what we're going to do is we're going to have some problems in this section that are a little different from yesterday that we're not going to have to graph. Okay? It's going to be a question that just says, look at the following equation and tell me the amplitude. And all you have to be able to do is look at a certain part of the equation, and there's a number that you have to focus on in the equation to find the amplitude. Okay, one number. So yesterday we learned that when you add or subtract inside the parentheses, okay, with the x, that's a phase shift. Well, amplitude change is a little bit different. Okay, amplitude change, first of all, uses multiplication. And the multiplication is in front. Bless you. Right? Multiplying by a number in front is an amplitude change. Right, so here's an example. 3 sine x. This means 3 times sine x. Right? Here's another example. Negative 2 cosine x. This one actually has two things happening. The negative is going to do something, and the 2 does something. We'll talk about what the negative does. And here's another one. 1/2 sine x. Okay, but they're all multiplying by a number in front. Okay, let me show you on the calculator what this looks like. So let's type in sine x. And then I'll type in 3 sine x. And you can see what the difference is. Okay, so that's the original, just the basic sine function. And here's the one with a 3. Okay, so you can see what it did to it. Right? By multiplying it by 3, it stretched it out 3 times as much. James, how high does the graph in blue go? 1. How about the one in red? 3. So we tripled the amplitude. Okay. Instead of having a height of 1, now it has a height of 3. Okay. So any question on what that looks like? Anybody have a guess what this would sound like if you played the blue sound versus the red sound? Have a guess what the difference would be? Yeah?
Have a higher pitch.
Okay, so that's one option. It could have a higher pitch. What would be something else that we can change about a sound? Yeah?
Like how loud it is?
How loud it is. And this would be how loud it is. Okay, the higher you make the amplitude, the louder it gets, or the stronger it gets. And with sound, stronger means louder. Okay. If you're talking about light is also a wave, take physics. And when we talk about stronger light, we don't mean louder, we mean brighter. So stronger can mean different things depending on what you're talking about. But with sound, it means louder. So, you might have guessed by now that the number in front is what controls the amplitude. And if you take the absolute value of that number, it will tell you the amplitude. Okay, so there is no reason you have to graph to find amplitude. You can just look at the equation and take the absolute value of the number in front. And when you take absolute value, what kind of answer do you always get? Yep. Positive. And that's because amplitude is measuring the height. There's no such thing as negative height, right? That's why we take the absolute value. So let's look at, let's actually look at these. And let's find the amplitude of these three. The first one, we already graphed it, but can anybody remind me, what was the amplitude of 3 sine x? Angelina? 3. How about negative 2 cosine x? What's the amplitude there? Yes?
2.
2. And what about 1/2 sine x? What's the amplitude for that one? Done? 1/2. What if I did this down there? What's the amplitude now?
Same thing.
Same thing. That negative doesn't have an effect on the amplitude. It does have an effect on the graph when we sketch it. We'll talk about what that is. What do you think the difference is between multiplying by a number in front that's bigger than 1, like 3, versus a fraction, like 1/2? What do you think the difference would be in how the amplitude changes? Yep.
With the 1/2, it's going to get smaller because it's really divided.
Yeah. So the 1/2 really means it's going to get smaller. The height would get half as high. So if you're talking about a sound wave, that would mean a sound that's quieter. If you're talking about a light wave, that would be a beam of light that's not as bright. Okay. So amplitude, again, we just said that, is always a positive number. And we just said these two things as well. Aiden just said that. So if you have a number in front that you take the absolute value of, and it is bigger than 1, that will cause it to stretch. Stretch, I mean get taller. If you have a number in front that has an absolute value of less than 1, like 1/2, that will compress the graph. And everything is happening along the y-axis today. Things are getting taller or shorter on the y-axis. So those are the values that are going to change today. Back to this picture. If you look at a point on the original graph and then look at the corresponding point on the red graph, that point ends up right there. If you write the coordinate for this point, we'll call this one point 1, call this one point 2. The coordinate for point 1, remember each one of these tick marks is 90 degrees. We talked about that yesterday. So this is pi over 2, comma, 1. It's at a height of 1. The coordinate, when you multiply by 3, it moves up there. Well, what value didn't change in the coordinate? Yeah.
X.
The x. It's still pi over 2. But now it's at 3. So you can see for today, the x's stay the same. When you do an amplitude change, there's no left and right movement. It's all up and down. All right. Any question on that? So, next step is to take our 5 coordinates that we know, and we have to transform them. What part of the coordinate did we just say is going to stay the same today? Yeah?
The x's are staying the same?
The x's are staying the same. And what's nice about the x's staying the same is the x's are all the fractions with pi. The x's are harder to work with. So today, we don't have to work with the fractions with pi. All we have to do is work with the y values. The y values are easy. There are zeros, ones, and negative ones. So we're only going to have to do arithmetic with those 3 numbers today. 0, 1, negative 1. So, what do we actually do? So the x's are staying the same. The y's are changing. To find the new y values, all you have to do is multiply the old y values by a. Notice there, I didn't say absolute value of a. I just said a. If the number in front is a negative number, use the negative, because the negative has an effect on the graph. The only time you take the absolute value of a is if I ask you the question, what is the amplitude of this graph? Don't ever give me a negative answer for that. Okay. But let's graph something like, we have 3 sine x. Let's do negative 3 sine x. Does anybody have a guess what the negative is going to cause the graph to do? Well, by putting a negative in front, does it change the amplitude? No, it doesn't change the amplitude. But the negative does do something. Yeah?
Invert the highs and lows.
Yeah, it's going to flip the graph over. So compare the one in red to the one in black. What's happening now is what was the highest point becomes the lowest, and the lowest becomes the highest. So a negative causes the graph to flip. Didn't change the amplitude at all, comparing the red and the black one. It just flipped. Now, it would be a little hard if you just looked at the red and the black graph to describe what happened there, because technically the red and the black graph could be a phase shift. You can't really tell if you took the red one and moved it left or right, or did you flip it to get this picture. You technically could have done either one. So you can't tell that by looking at it. But that's what a negative does. Causes the graph to flip. So let's try an example. So 3 cosine x. First thing I'm going to do is make my table. And then I'm going to figure out what kind of transformation this is. Okay, now we know 2. We know phase shift, and we know amplitude change. Can anybody tell me why that is an amplitude change? Yes?
It has its multiplication and its multiplying.
Can you just say it again?
It has its multiplying and its before the cosine.
Yep, exactly. It's multiplying and it's in front. That's what makes something an amplitude change. And if you're like, well, where else could you multiply? You could multiply like this. That's different. That's multiplying inside the parentheses. We'll look at that tomorrow. Okay. Today, it's multiplying in front. So Ben, when I multiply in front, what values are not affected?
Y. Or no, X.
Which one?
X.
X. The X's remain the same. How about James? Can you tell me what my X's are?
-2, -1, wait, no.
X's are all going to have pi's in them,
Oh,
except the first one.
0, pi over 2, pi, 2 pi, 4 pi. The pi over 4. Wait,
Well, this is technically pi over 4, but we just say pi over 2.
yeah. Pi over 2, pi, 0, 2 pi, and 4.
Not quite. I like the first 3. Those are good. Mateo?
3 pi over 2,
3.
and then 2 over pi.
And what's the last one?
2 over pi.
We never have pi in the bottom. So no matter what we do this week, don't ever put pi in the bottom of a fraction.
Oh, wait, yeah, you're right. I was doing that for mine.
What's this last one?
2 pi.
2 pi. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are going to be the x values for every problem we do in class today, for every problem in the homework tonight. They never change for today. Now, I need my new y values. What I'm going to do is write the originals, just like I do for phase shift, and leave a little bit of room to do some work. How about, Jacob, can you give me my original y values for cosine?
1, 0, -1, 0, 1.
Okay, so there's my original y values. And Lacey, what am I going to multiply all those by?
3.
3. And Autumn, can you tell me what my new y values will be?
3, 0, -3, 0, 3.
There we go. All right. So arithmetic, a little bit easier than yesterday. Questions on the table? Okay, grading for this kind of problem is exactly the same as yesterday. If you get 1 point for each x and y value you get right, that makes this table worth 10 points on a test. 10 points out of 100 for the test. All right, now let's do our graph and see what we get. Now, we can do the graph a couple different ways. What I usually do is this. That's 0, and that's always 0. You can't change that. The axes are always 0. But the highest I have to go is 3, and the lowest is -3. So I'm going to change the scale on my y-axis. 3, -3. Just like that. Now I'm going to label the other tick marks, because if I don't label these marks, then I'm going by ones. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is not my x values. Okay. Those are my x values. So pi over 2, pi, 3 pi over 2, 2 pi. And those numbers, if you look at it in degrees, are just nicely spaced numbers by 90. That's 0, 90, 180, 270, 360. Okay. All right, let's graph our points. 3, 0, -3, 0, 3. So 3, 0, -3, 0, and back to 3. Okay, remember that again, it's a part of a wave, so try to make it look like that. And it would continue on, like that. We don't have to keep drawing it. Okay, any question on that? So a lot of the graphs I do today are going to look the same because I'm going to change my scale. So let's say they wanted me to graph 7 cosine x. If I wanted this problem to represent 7 cosine x, all I would have to do is this. Now that's a graph of 7 cosine x. So that's why all my graphs today are going to look the same, because I'll be changing my scale. Right? It's a lot easier to change my scale than to try to graph something 7 times taller, because then it would be huge. Let me just put that back the way it was. There we go. Okay. Questions on that one? All right, so in terms of sound, that would be a louder sound. Okay. Would it necessarily be 3 times as loud? I'd have to think about that a little bit. Okay. It'd be louder. Okay. When you talk about sound, you really measure it in decibels, so you have to take that into account, things like that. Let's look at 1/2 sine x. All right, so how about Olivia? Can you tell me what kind of transformation that is? A phase shift or an amplitude change?
An amplitude change.
That's an amplitude change. And what makes it an amplitude change?
The 1/2 in front of the sign.
And what do you do? What operation are we doing?
Multiplying.
We're multiplying. Multiplying by a number in front. Okay, so that's an amplitude change. Alright, so amplitude change. Ava, what values stay the same?
X.
Yes. And can you tell me what my x's are?
It would be 0, pi over 2, pi, 3 pi over 2, and 2 pi.
Yep. So there's my x's. Now, I'm going to write my original y's, because then I'm going to modify them. Jody, what are my original y values?
1.
So it starts with 1 if we're doing cosine.
It's 0,
Yeah.
1, 0, negative 1, 0.
Good. So 0, 1, 0, negative 1, 0. Perfect. And Katrina, what are we going to multiply all those by?
1/2.
We're going to multiply them by 1/2. Okay. So times 1/2. And then we'll write our new y values. So how about Colby? What would my new y values be?
0, 1/2, 0, negative 1/2, 0.
There's my table. Right, questions on the table? All right, now technically this graph would look half as tall if you compared it to a graph without the 1/2, but I'm going to scale it. So this is 0, that's 1/2, that's negative 1/2. So it's going to look exactly the same as it always does. Okay, so I got those labeled. Next thing I need to label is my x-axis. 0, pi over 2, pi, 3 pi over 2, 2 pi. Now plot your points. 0, 1/2, 0, negative 1/2, 0. Okay, 0, 1/2, 0, negative 1/2, 0. Again, this is part of a wave, so try to make it look that way. That's it. That's your sketch. Okay, any questions on that? All right, let's try one more, and then we'll look at the last transformation today, which is a vertical shift. Okay, negative cosine x. What's the amplitude of this one? Angeline? 1. Okay, if you're wondering, well, how do you get 1? Well, you can always pretend like there's a negative 1 in front. And amplitude is the absolute value of the number in front. So technically, the height isn't changing at all. It's going to have exactly the same height we always have. But what is going to happen? Yeah, Jake?
They're going to be flips, positives will be negative, and negatives will be positive.
Yeah, the graph is going to flip, or it's going to be a mirror image over the x-axis. So, x's stay the same. Hopefully after you write these enough times, you'll start to remember what they are. And now the original y values would be 1, 0, negative 1, 0, 1. Those are all going to get multiplied by negative 1. So we're going to have negative 1, 0, 1, 0, negative 1. There's my table. Any questions on how I got my y values? Okay, so let's set this up. 1 and negative 1. Yeah, 0, pi over 2, pi, 3 pi over 2, 2 pi. Again, I put my labels down there so I don't end up drawing over them. Okay, so -1, 0, 1, 0, -1. So this, normally when we sketch cosine, it's the part of the wave that's dipping down. This is the part of the wave that's going up. Like that. Okay, any questions on that one? Right, so that pretty much covers amplitude change. So the last transformation we're going to look at today is a vertical shift. Now, we've done shifts. We did a phase shift yesterday. What math arithmetic operation was involved when we did a shift yesterday? Yes? Addition and subtraction. Anytime you do a shift, it's always addition or subtraction. Where you do the addition or subtraction controls what kind of shift. Is it a left and right shift? Or is it an up and down shift? So this has addition or subtraction, but notice the difference from yesterday. It is outside parentheses. So an example of a vertical shift would be something like that. Sine of x plus 2. Now, if you put the x and the 2 in parentheses, now you've just made it a phase shift. That changes the order of operations. So if you were doing this out as a problem, you wanted to plug a number in for x, the order of operations would be take the sine of x, then once you get that answer, add 2. Compared to when you do something like this, that says add 2 to the number that you plug in, and then take the sine of that. Right? So it's a difference in order of operations. There's another example of a vertical shift. So when we shift, we know there are 2 directions we can go. Yesterday was left and right. Today this is up and down. What do you think sine of x plus 2 is going to do? Shift it up or shift it down? It is up. So yesterday it was the opposite of what you would think. Today it's not. Plus is up, minus is down. Okay, so a vertical shift will move it up if you add, down if you subtract. So let's think about what that would do to a coordinate. If you took just a single coordinate and you moved it up or down, what changes in the coordinate when it moves straight up or straight down? What changes? James? The y part of it. Okay, the y part of it is what is going to change. The x does not. And that's why we did both of these transformations together today. Because both of them change the y values. And they're easy. Right? The arithmetic is very easy to do. You'll find the arithmetic just as easy on this one. Okay, so how do you find your table? How do you get those 5 coordinates for a vertical shift? Well, x's stay the same. So the x's are going to be the 0, the pi over 2, pi, 3 pi over 2, 2 pi. The y's are going to change. So to find the new y values, all you have to do is add or subtract whatever the number is at the end of the problem to the original y values. And I use d because that's what I use to explain it right here. So if you see a plus 2, you're going to do plus 2 to all the y values. If you see a minus 3, you're going to do a minus 3 to all the y values. Don't do the opposite. And people always mix that up, but I don't know how to say it any clearer. And don't do the opposite. Just hold it up higher. There you go. All right. So again, all you're going to have to do is add or subtract a number to a 1, a 0, or a -1. That's it. And don't do the opposite. Do exactly what you see in the problem. All right, so y equals sine of x plus 2. Now we know 3 different kinds of transformations. We know the phase shift, we know the amplitude change, and we know the vertical shift. Which one is this? And I want to know why. Yeah, Don?
Vertical shift because it is addition and it's on the outside.
Yep, it's addition and it's outside of parentheses. The only way it can be a phase shift is if it is in parentheses with the x. This makes it a phase shift. That does not make it a phase shift. Doing something like that doesn't make it a phase shift. Kind of weird to put parentheses, but you could. The only way it's a phase shift is if the x and the 2 are together in parentheses. Anything else, like Dom said, it's on the outside, it's a vertical shift. So Dom, what column here is unaffected by moving something up or down? X. So those are the x values we're going to use. And how about, Lacey, what are my y values for sine?
0, 1, 0, -1, 0.
0, 1, 0, -1, 0. Okay. So those are the originals. And Autumn, what am I going to do to all of them?
Add 2.
Add 2. Okay, so plus 2, plus 2. All right, so we get 2, 3, 2, 1, 2. Done. All right, any questions on my table? Now, when I do my graph, let's see, I got to go up to 3 on the y-axis and down to 1. So let's, think that'll work. Perfect. And this time, you can put your labels right here. And I know I'm not going to draw over them because I'm shifting the graph up. So my graph is going to be up in quadrant 1. It's not going to go down into quadrant 4. All right, so 2, 3, 2, 1, 2. 2, 3, 2, 1, and 2. Usually when I do this on like a paper test, you have to graph paper already on the test, so it makes it easier to keep things lined up. Right, and there's your graph. As far as the connection with sound on this one, I don't really know one. So the phase shift, you heard what that sounded like. Amplitude, I didn't play what it sounded like, but just imagine something getting louder and quieter. That one's not super interesting. What's the amplitude of that graph? Yeah?
2.
No, it's not 2. Yep. It's 1. Remember that amplitude is the height off of the center line. So if you put a center line in, well, now I messed it up. Kind of like this. The height there is 1. It's just 1 unit off it. All right, and let's finish up with this one. Y equals cosine x minus 5. Okay, we got parentheses there. So does that mean we have a phase shift? Yep.
No, because the subtraction's outside.
Yeah, you would still, order of operations, you would still take the cosine of this value first and then minus 5 at the end, okay? You wouldn't minus the 5 from the x first and then take the cosine of x minus 5. Okay? So that is still a vertical shift. All right, vertical shift, 0, pi over 2, pi, 3 pi over 2, 2 pi. And Jacob, what's going to happen to all my y values?
They're gonna subtract the 5.
Yep, we're going to subtract 5. They're all going to move down 5. So I would have 1, 0, negative 1, 0, 1. And Ben, can you tell me what I get when I shift those? All right, so what are we doing to each one of those? What did Jacob just say we have to do to all of those? Can you say it again, Jacob?
Subtract them by 5.
Subtract 5 from all of them. So what do we get when we subtract 5 from each one of those?
0.
So, that's a negative something. Negative 4. Good. So those are my y values. Questions on how we got those? All right, let's make our graph. So this time I set it up, because I knew my y values were all going to be negative, I set up my graph really just down in quadrant 4. So I've got 0. I need to make this a little smaller because it's too big for me to see on the screen. Alright, so got that. Now let's go put our x's. You're fine to put your x's right here. No chance we're going to draw over those because everything's going to be shifted way down. Negative 4, negative 5, negative 6. And back to 4. All right, and now sketch that as part of your wave. There you go. All right. So now we've covered at this point the phase shift. Did that yesterday. The amplitude change and the vertical shift. The last transformation we have to cover is another stretching one, but it's not stretching up and down, it's stretching left and right. Right? And that's the one where we can start to play some interesting sounds and start to get into kind of some interesting things that can happen. So we'll take a look at that tomorrow. So homework for tonight is a worksheet. It's on Schoology. It's 2.4 part 2. If you guys want, I can just show you real quick in the video where it is. So go to 2.4 part 2. It says amplitude change and vertical shift. Click on it. Click on the homework. And then it's the PDF file right there. Worksheet and amplitude shift, vertical shift. So you can print it if you want. Some of you just did it on a scrap piece of paper, that's fine. But remember, to get full credit for it, you need to show the table with the 5 points and the sketch. Okay, if you only have one or the other, I'm giving you half because you missed half the question.